Yes,
Yes, sir.
This module 1. Okay, so module 4 we will discuss. So this is solving ordinary differential equations with the constant coefficients, maybe the non-homogeneous terms also involved, like this. Okay, like this. Okay, so to the extension of this, we saw that two different definitions. One is unit step function and another one is unit impulse functions, or Heaviside or Dirac delta functions. Okay, that is a separate file I shared to you. Okay, so now we are going to discuss the thing with the simultaneous differential equations with this same portions. Okay, the simultaneous differential equations we will discuss. Solving by Laplace transform. Okay, so that's a new thing to us today, and solving PDE also by Laplace transform. Okay.
That simultaneous one, it is there in our syllabus, sir.
We have it, but solving system of equations, right? You have doubt? This is a syllabus, right? Differential equations and transforms. See, solving non-homogeneous system using Laplace transform. Fine.
Okay, sir.
And solution of first order PDE by Laplace transform. So that we will discuss. Okay.
So today you will start fifth module or tomorrow, sir?
What?
Today you will start fifth module or tomorrow you will start, sir?
If I completed the fourth module, okay, I try to finish it is by taking maximum of 1 hour. Okay, if I completed, then I will start with the fifth module. Okay, fifth module is very easy. If you know the integrations and all, and the new thing is you should know the corresponding formulas, how it is derived. Okay, and in what situations we have to apply the respective or the kind of formula. That if you understand, then that is very easy. Okay, no matter that I will take care of you. Okay, so solving system of equations. Okay, so that's our new concepts today. So do you know how to solve the system of equations? Okay, so solving simultaneous or system of equations, systems of equations by Laplace transform. That's a concept. Okay, in other method also we can solve. Here the equations solving system of ordinary differential equations. That's also an important one. Okay, the derivative is involved in your differential equations. Okay, so in general, suppose I am having the equations format like this: a1x or this b1y plus c1z equals to some d1, a2x plus b2y plus c2z equals to d2, then a3x plus b3y plus c3z equals to suppose d3. So this kind of equation, suppose I am having to compute this xy is at, okay, first method, the substitutions method we can get. Okay, the elimination method or the substitutions, okay, we may use it. Elimination means we are going to first eliminate some z value, multiply with some constant of number of these equations, okay, and subtract from this. Okay, that eliminations method we can use it. Okay, or Cramer's rule, you know that, right? Cramer's rule. What about Cramer's rule? In this system, if I want to compute this x means we are going to replace this a1, a2, a3, the x coefficients by the non-homogeneous term d1, d2, d3, that is called by delta. Okay, suppose I am using delta, remaining it is b1, b2, b3, c1, c2, c3. Okay, so here it is my actually delta means it's a common one, irrespective of this actually this a1, a2, a3. Then delta x, if I want to compute, then that time the first column will be replaced by this d1, d2, d3, remaining b1, b2, b3. Here it is c1, c2, c3. So that here x, if you want to compute, this is nothing but delta x divided by delta. Okay, so that should compute. So likewise, if I want to compute y means y is a delta y by delta and z b is delta z by delta. So delta y means the second column should be replaced by d1, d2, d3. Delta z means third column should be replaced by this d1, d2, d3, remaining as it is. Is it clear? Students? So give me quick response. Give me quick response. So here, one more other method among this any three equations. Suppose I am going to take any two equations. If I am considering, so a1x plus a2y plus a3 sorry b1y plus c1z equals to d1. Any two equations. Okay, a3x plus b3y plus c3z. Any two equations I may take. That's why the changes I am taking. So if I want to compute this xyz for the homogeneous system, okay, for the homogeneous system, if I want to apply, so just I am going to use it. Okay, this irrespective of this d1, d2, d3. Okay, suppose I am going to have this is 0 and this is 0 for the homogeneous system. Okay, now this coefficients I am just directly writing two types. Okay, a1, b1, c1. And then this is a3, b3, c3 twice. Okay, a3, b3, c3. So now eliminate this first and last coefficients. Then x is nothing but multiplication of these things. Determinant of this b1, c3 minus c1, b3. So you know that in the determinant concept, in this direction is positive and this above direction is negative. And this y is calculated by these two things. Okay, this is a1, b1, c1. X should calculate with these two things, and y should calculate with these two things here and here. Then z is calculated with these two things. Okay, so in this way also we can solve the equations. Why I am giving this? So sometimes in the middle, so this method is called the cross multiplications method. Okay, this is called cross multiplications. So by cross multiplication means, okay, so this x means taking this b1 c3 minus c1 b3, and y means this c1 a3 minus this a1 c3. Okay, this one, and z means a1 b3 minus b1 a3 minus b1 a3. That's the thing. Okay, see here a1 b3 minus b1 a3. So this is my xyz computing manner. Yeah, we will see some problem. Okay, solve. Okay, in this method, okay, solve the simultaneous equations just by the Laplace transform. So this is x dash. X dash is suppose it is 2x minus 3y. Okay, and dy by dt is suppose given in this way. It is y minus 2x. With it is first order equation. Here it is first order equations. So two initial conditions we need. So x at 0 is 8 and y at 0 is 3. Okay, how to solve? So the solution of this equation. Okay, solutions if I want to find. Okay, so this is my x dash of t minus 2x. Am I right? Minus 2x plus 3y equals to 0. Then y derivative of t given equations, given plus 2x minus y equals to 0. Sir, is it clear?
Yes.
Okay, so these two equations here we are having. Now applying Laplace transform on both sides. Okay, applying Laplace transforms on both sides. Applying Laplace transforms on both sides. We get, so can you tell me with this equations, Laplace transform of x derivative of t minus 2 into Laplace of x of t plus 3 into Laplace of y of t, which is Laplace of 0. Then what is that? This is can be written as s into x of s. Am I right?
Yes, sir.
Minus x of 0. Minus 2 of this is x of s plus 3 into y of s, which is 0. Okay, substitute the initial condition. X of 0 is 8. So x of s, suppose I am going to collect s, this is minus 2 plus y of s, and this will be minus 8. Am I right? Equals to 0. Is it clear?
Yes.
And this y derivative of t plus 2x minus y, if I am considering that L of y derivative of t plus 2 times of L of x of t minus L of y equals to Laplace transform of 0. So this is x into y of s minus y of 0 plus 2 times of this x of s minus y of s equals to 0. Then this y of 0 condition is, it is 3. So that here it is y of s into s plus 2 minus, oh here it is minus 1 is also there.
Sir, can you scroll up little, sir? Okay, sir.
Okay. This is not a x of s, right?
S minus 1 is.
Yeah, this is s minus 1 only because this is x of s, right? Minus 3 equals to 0. So this and this and this, okay, from star and double star, the equations, if I am considering that, this is considering that, okay, s minus 2 x of s plus 3 into y of s, minus 8 equals to 0, and then it is 2 times x of s with this equation, plus s minus 1 times this is y of s minus 3 equals to 0. Sir, how to solve this in terms of for these equations? Solve for x of s, okay, this x of s and y of s how to get the solution of this? By cross multiplications. Okay, by cross multiplication. Suppose I'm going to use it. Okay, x of s means these two things, 3 into minus 3. Okay, x of s over this 3 minus 8, s minus 1, and then this is minus 3. And then your y of s means, just consider this is y means this c1 should be in the first place, c1 c3 in the first column, and then this a1 a3 in the next column, like that. This minus 8, that same number should continue, minus 8 minus 3, then this is s minus 2 2. Okay, s minus 2 then constant I am going to compute 1 upon here my z. So whatever we are having, that should continue. Okay, and the remaining of that, below of that, we should remove, and remaining of that. Okay, this is the thing. Okay, just using this by cross multiplications method. So what is x of s? X of s, just getting this minus 9, minus 9, this is minus into minus, plus 8 into s of s minus 1. Sir, is it clear?
Yes, sir.
How we are writing this class multiplications method? Okay, so it is minus 16 and then plus positive 3 times of s minus 2 equals to 1 divided by this is s minus 1 into this s minus 2 minus 6 minus 6. Or simply if you are writing this x of s divided by 8 times s, 8 times s minus 8 minus 9, so overall it is minus 17. Then y of s is, it is 3s minus 6 minus okay, this is minus 22, am I right? And 1 divided by this is s square minus 3s, s square minus 3s plus 2 minus 6, so minus 4. Okay, so so this x of s, this implies that already in your sum of the problem we discussed, here it is some non-zero constant k is there, so just we are going to multiply this x of s and then this 8s minus 17. Even in our Lagrange's method also PDE, we assumed that this is s square minus 3s minus 4 and this y of s divided by 3s minus 22, 3s minus 22, and here we are, suppose we are going to assume that 8s minus 17, right? Yeah, this is equals to 1 divided by s square minus 3s minus 4. Okay, then what about x of s now? X of s is 8s minus 17 upon s square minus 3s minus 4. Is it clear? Sir, apply inverse Laplace transform. Can we written it as something like minus 4 will be the product and then this minus 3 will be the sum. So 1 and 4, adding it is we are getting my product. Yeah, we are having this. So that s plus 1 into this s minus 4 factorized form. So 8s minus 17 upon this s plus 1 into s minus 4. This is my x of s, and my y of s is, it is 3s minus 22 divided by s plus 1 into s minus 4. Okay, apply inverse Laplace transforms. Okay, apply inverse Laplace
Sir, I
transforms.
think it should be s square plus 3s minus 4.
What, ma?
Sir, it should be s square plus 3s minus 4.
This one.
Yes, sir. So in the y of s, you check the denominators once, sir.
Both the terms containing in this s square minus 3s minus 4 and y, right? See, consider this equation is in this way. This and this, this and this. Okay?
Yes, sir, got it.
Okay, this s square minus 3s by 4, s square minus 3s by 4. Both the terms should contain the same thing only. Okay, s plus 1. Okay, apply inverse Laplace transform. Okay, so that L inverse of x of s means nothing but my solution x of t. So L inverse of 8s minus 17 divided by s plus 1 into s minus 4, and L inverse of y of s is, this is my y of t, the solution. So that L inverse of my 3s minus 22 upon this s plus 1 into s minus 4. Okay, so here this 8s minus 17, L inverse of this x of t, L inverse of 8s minus 17 divided by s plus 1 into this s minus 4 by partial fractions. Okay, by partial fractions we may write this is a divided by s plus 1. Am I right? a divided by s plus 1 plus b divided by s minus 4. 3s minus 22 s plus 1 into s minus 4. This is also a divided by s plus 1 plus b divided by s minus 4. Sir, is it clear?
Yes, sir.
Okay, now substitute this is when s is 4, when s is 4, when s is 4, this is vanish. Okay, as a first substitute s is minus 1, then b is vanish, then my minus 1 into minus 4 is minus 5a, minus 5a here in the right side, whereas in the left side minus 1 if you are substituting, so minus 8, minus 17, so it is minus 25, so overall it is 1 by 5, am I right? Sorry, 5. A is 5 divided by s plus 1, and when s is s is 4, okay, it is a 8 4s are here, it is 32. Okay, then 32 minus 17. Here how much we are having? 5. Is
15
it clear?
equal to 5b.
How much per?
15 equal to 5b.
18 equals to 5. Check the value whether it is I am doing correct or not.
Equal to 5b.
One second. Yeah, 18 equals to 5e, right? Right, 18 equals to 5b, am I right? Sir, is it right? Then for this apply inverse Laplace transform. What is my x of t? So 5 I am taking out, remaining e raised to the power minus t plus 18 divided by 5, 18 divided by e raised to the power 40. Is it clear?
Sir, I think it's 15 by 5.
Then it's
Yes,
3.
sir.
How it
B-
is?
E.
So here you
17.
have, so it is 32 minus 17, am I right?
Yes, sir. Then it's 15.
Okay, 32 means, okay. So it is 15. So 15 by 5 means it is 3 only, right? It is 3. Then 3 times of 4 power t. Yeah, okay, right, you are right. Then here compute this value y of t. This is L inverse of 3s minus 22 upon s plus 1 into this s minus 4. S minus 4 is can be written as again the same thing, L inverse of a divided by s plus 1 plus b divided by s minus 4. So here substitute s equals to minus 1, s equals to minus 1, then b is vanished, then it is minus 5 times a, which is here it is minus 1 means it is minus 25, so overall it is 5, overall here also it is 5, so 5 times of L inverse of 1 divided by s plus 1, I am directly writing. Okay, then this is okay when s equals to 4, when s equals to 4, so 5b which is equals to, okay, so it is minus 10, am I right? So b is minus 2, so minus 2 into L inverse of 1 divided by s minus 4, so 5 into e raised to the power minus t minus 2 into e raised to the power 40, this is my y of t. So the solution of the system in your exam, you just highlight the result, okay, whatever the problem, at the end you just write your answers properly like this. Okay, what is your answer? So here it is 5 into e raised to the power minus t plus 3 into e raised to the power 4t. It is 5 into e raised to the power minus t minus 2 into e raised to the power 40. That's all, sir. So what we done here, this process, just we are taking the Laplace transform on your system of equations. Okay, Laplace transform on both sides of the equations, apply the derivative formula, substitute the initial conditions. Okay, then we are going to frame the system of equations by using cross multiplications method or any other method. We just try to get this what is x of s and y of s. Once we obtained that, apply the inverse Laplace transform, maybe the inverse Laplace transform, you may use the convolutions or partial fractions and add and subtract, multiply and divide. For the small adjustment technique, we compute this x of t and y of t, and thus will be the solution of our systems. Sir, is it clear? Am I right?
Yes, sir.
So one more problem on this topic. Okay, solve d plus 1 into x plus d minus 1 into y, which is equals to 1. Then minus 2x plus d minus 1 into y equals to 0 with x at 0, 0, y at 0 is 1. So the solution of the problem, now we are going to apply. D means nothing but dx means it is dx by dt. dy means it is dy by dt. So which means that it is x derivative, this is y derivative. Is it clear?
Yes, sir.
So this is given is x derivative plus x plus y derivatives minus y equals to 1, minus 2x plus y derivative minus y equals to 0. This is the given equation. Okay. Apply Laplace transform on both the equations. Okay, on both the equations. We get L of x dash. Shall I write directly? Because you know that this is s into x of s plus L of x is x of s plus s into y of s minus y of 0. I think here this x of 0, I think I missed. Am I right? Or this? Sir, am I right?
Yes.
Okay, minus y of 0. So which is equals to Laplace of 1 is 1 by s. Okay, now minus 2 times of x of s plus s into y of s minus y of 0 minus y of s. Okay, it is equals to 0. So given condition, x of 0 is 0, y of 0 is 1. Given initial
Sir,
condition.
can you show the question, sir?
Yeah, here itself question pa. Why you are asking again and again? The same is also the question. At the end, definitely I will share the file. Okay.
Sir, in the first equation, there should be one more y by y of s minus y of s.
Where pa?
Sir, in the first equation, and the last we have to subtract.
Yeah, this you are telling, right?
Yes.
Yeah, don't consider pa. See, sorry. So here, okay, this problem I am giving you. Okay, so the problem again I am giving, right? Okay, the given equations I written. The alternate form, whatever it is given at the end of the class, whenever I share the file, you just take their problem. Okay. And because see already one problem we take half an hour means even I cannot complete this module itself. Then one more day we have to go for it. Okay. That's why I'm asking, please give me the quick reply. So for this, so if you are substituting this x of 0 is 0, then this will be vanish and there is no more x of 0. So x of s, if I am collecting, what will be the thing here we are having, which is s plus 1. Okay, and y of s we are going to collect. Y of s means it is s minus 1. And this is y of 0 is minus 1, right? Y of 0 is 1. Sir, is it clear?
Yes, sir.
Whether this 1 is coming, or any y of s or something will be get cancelled? No, huh?
sir, the minus 1 will also be there.
Minus 1 also there.
Yes, sir, minus y of 0 is there in the equation.
This we are getting, right? And here x of s means only minus 2 only. Minus 2 only. Okay, then this equation, here it is y of s means s minus 1, right? So here also minus 1 equals to 0. Is it clear?
Yes, sir.
Okay, minus s into x of 0 plus x bar okay, plus s y minus y of 0 bar plus y bar. Okay, so can we reduce this equation? Can we reduce this equation in other form? Because
So
here,
we can subtract the equation.
yeah, here in this previous problem, if you look at this, okay, let's look at these equations. Okay, x of s, y of s, and constants are there. Okay, in this equation itself, x of s and y of s involved. Here also the same way. Shall we go for with your x of s? This x of s means remaining these two, right? Remaining these two, s minus 1 and then s minus 1. This is minus 1 means definitely it is going to be produced 0, right?
Yes, sir.
Okay, then how can we compute using that? Okay, do one thing. This s is there, na? This s is there, right? This s is there. Consider this x of s into s plus 1 plus y of s into s minus 1 minus s which is equals to 1, right? So minus which is equals to 1, then this implies that x of s into s plus 1, just cross multiply. Is it clear?
Yes, sir.
Okay, minus of s plus 1, suppose I am having it. Okay, then only we can get, otherwise it will get, makes the problem. So again this equations, so x of s into minus 2 and then this y of s into s minus 1. No, here it is, there is no x mere multiplying. Okay, s minus 1 only, and here it is minus 1 equals to 0. Now if we are solving this, this equations with your x of s format. So these two things, s into s minus 1, s into s minus 1 upon this x minus 1, this one. Okay, then here it is minus s minus 1 and this is minus 1. Okay, and your y of s becomes, okay, y of s means whatever we return, the same thing we have to write again. So minus 1, then the remaining it is here it is the coefficients to the right side of this we return. Then the circular motions, see this is my x and this is my y and this is my constants. So we are having a circular things. If I am computing this x, first column should be of y, then second column should be of the constant. If I am going to compute for y, first column should be of my constant coefficients, okay, and next column is my x coefficients. X coefficient is, this is x into s plus 1, then it is minus 2. Then the constants, if I am going to compute, first column should be of x, so that s into s plus 1. Then the second column should be of my y, s into s minus 1, and this is my s minus 1. Sir, is it clear? Okay, so this is the way here we are at. So what is our x of s? This is minus s square, okay, and this is minus into minus plus s, multiplication of these things, s minus 1 into minus s minus 1. So overall it is minus s square, right? I'd put one more minus, I think. This thing is positive and this thing should be negative, right? So shall I make this as positive, both the things? Sir, by determinant property, s square plus s minus 1. So this minus s here itself cancelled, so that it is s square minus 1. Then this s square get cancels. Okay, so that here we are having remaining, it is s minus 1 alone. S minus 1 alone. So y of s part, it is minus positive 2s, positive 2s, positive 2, and here it is minus into minus plus. So positive s square, and then here it is and this will be positive s, right? Positive s. So overall that here we are having 2s plus 2. It is s square plus 3s plus 2. Am I right? Students?
Yes, sir. S square plus 3s plus.
And yeah, give me that, give a proper value. So it is s square plus 3s plus 2. Okay, then this constant, if I want to compute, okay, constant means the same column here we are having s square plus 1. Actually it is here itself, it is s square plus 1, s square plus 1. It is s is here plus s multiplied with s minus 1 plus 2 times of s into s minus 1. So here it is s cube. Am I doing anything wrong? Because it is s cube is coming. How can we solve that?
Sir, it's correct only.
It's correct only, yeah. Because if you are multiplied with the s minus 1 means it is s cube, right? It is minus s square, then plus s square, minus s, plus 2s square, plus 2s square, s square plus s is there, right? Then 2 plus 2s. This and this get cancels. Then s cube plus 2s square minus s plus 2s means s cube plus 2s square minus s will be the things. Then what will be the root for this? Factorized form we need to get, right? I think one s is extra portions for this. Where it starts? Just go through that. This equations of whether it is multiplied by x. Yes.
Sir, the cubic equation should be s cube plus 2s square minus 3s. So s we can just take out common.
Yeah. Okay. 1 minute. This first equation. Okay. Okay. Cubic equation is okay, but this problem is fine, right? Here we are having that. What is that? Here it is a s cube plus 2s square minus s, right? Up to this is correct. Okay. Up to this is correct. Okay. Now, if we want to compute this x of s, then this is nothing but this s minus 1 divided by s cube plus 2s square minus s. Is it clear?
Yes, sir.
Y of s means s square plus 3s plus 2 divided by s cube plus 2s square minus 1. So what will be the partial fractions here? The root of this one, s cube plus 2s square minus 1. Can you give me the equations? Okay, do one thing. The next upcoming classes, okay, I will give the solutions and all. Okay, now you know the procedure, right? Applying this L inverse of x of s and applying this L inverse of y of s, we will get the solution of x of t and this y of t. Is it clear?
Yes, sir.
So this is under the partial fractions. In your free time, you may do it. Okay. Otherwise, maybe the next class or the tomorrow, I will give you the solutions for this. Okay. I will give some gap. So I try to touch the next part because the partial fraction itself, if you are wasting your time, means we cannot cover that. Okay. So the next part, this is simultaneous equations. It is okay, or simultaneous equations or system of differential equations part is okay, but the other topic is in the same module we have that solving the boundary value problems involving partial differential equations. Okay, in general, if I want to have this equations, okay, so I will give the directly the theorem I am going to give you. Okay, so it is very helpful to you. Initial conditions and boundary conditions means, so suppose a partial differential equations along with some certain conditions are prescribed, okay, based on the physical situations. Okay, the conditions which are given for at a time t equals to 0 initially are known as initial conditions. Initial conditions means that condition should be defined for that x derivative and all other higher derivatives at same point, maybe t equals to 0 or t equal to b, like that. But the boundary conditions means it is given by in the certain interval form, the region or interval, okay, it is given. Okay, so boundary value problem means actually the conditions are known as your boundary conditions. That condition should satisfy your given PD. That kind of problem is called boundary value problem. So solving the boundary value problem or boundary value partial differential equations by Laplace transform is by using this theorem. Okay, given solution of PDE, first order PDE only, here we are restricted. Okay, first order PDE by Laplace transform. This is the topic. So theorem. So theorem we are going to have it. Okay, suppose I am having this, given the function y of x comma t is defined. Where it is defined? It is 0 less than or equals to, or a less than or equals to x less than or equals to b. Okay, where time t is positive. Okay, let this y of x of t regarded as a function of t. Okay, regarded as a function of t. Okay, function of t is some exponential form. Okay, exponential order as t tends to, even Laplace transform also this exponential order we discussed. Okay, so if it is of exponential order, then only that that function can be founded by this Laplace transforms. Okay, the same continuous for partial differential equations also. It is of exponential order and piecewise continuous over every finite interval, t greater than or equals to 0. Then this is the conditions we are going to use. Okay, Laplace transform of suppose the function y of x comma t is given. See here it is a function defined in form of y. So a Laplace transform of y of x comma t is by the definitions 0 to infinity e raised to the power minus st y of x comma t dt. Am I right? Students?
Yes, sir.
So this is y bar of x comma s, which is equals to y bar. Okay, this is y bar, suppose assuming that. So L of y of x comma t can be written as nothing but y of x comma s or y bar of x comma s. Okay, both are same meaning only. Okay, now here partial derivative with respect to x. This function in terms of y, if it is by finding the partial derivative of y with respect to x means, this is nothing but can be written as yx of x comma t. Is it clear?
Yes, sir.
So this can be written as yt of x comma t. Okay, these are the partial derivative. Suppose dou by dou x of at x equals to a, the partial derivative computing at x at a, then this can be written as y at in this place, x place we replaced by a. The same way dou y by dou t at t equals to 0 means we can written as it is yt at 0 comma t. Is it clear? Sir, I think yt of x comma
Yes.
0. I think this is x comma 0 because in t place only we are replacing it is right. It is x comma 0. So the corresponding Laplace transform. What about this Laplace transform? Suppose I am going to take the Laplace transform of this, because Laplace transform of x dash we know that it is s into x of s minus x of 0. Like that the derivative formula we are having. Then the same thing for if it is we are going to take the Laplace transform for the function if it is the partial derivative. So the first case here we are going to have this Laplace transform of dou y by dou t, either this manner or this manner. If it is given with respect to t means this is our usual formula, s into y bar of this x comma s minus y of x comma 0. Okay, y of x comma 0. Similarly, the second derivative can be computed. Okay, similarly here the second derivative is not provided, but I am going to give you. Similarly here dou square y divided by dou t square if you are having, then s square y bar of x comma s minus s into y of x comma 0 minus y with respect to time x comma 0. Okay, this is the thing. Okay, so in this way for third order and any nth order we may use it. Okay, and Laplace transform of these things, Laplace transform of dou y with respect to dou x, if I want to compute, it is nothing but first the ordinary derivative of my y bar of this x comma x only we are going to compute. Okay, so okay, in this way what about your L of y double derivative with respect to x? Laplace transform of dou square y by dou x square means what? It is d square by dx square y bar. Okay, so these are all the extra formula. It is similarly from this we derive. Okay, and for this dou y by dou x at yx at a means this here we are going to replace this x by a, and here at t equals to 0 means here we are going to replace that t form, it is equals to 0, right? So here we are going to apply. So for this we don't need. So only these two things we needed. Okay, so this is the Laplace transform to apply the things for solving the first order differential equations, partial differential equations. That's also an important one. Now we are going to check with this. Okay, so boundary value problem. Consider the boundary value problem. Find the bounded solution Find the bounded solution. Okay, y of x comma t, where x lies between 0 and 1 and my t is positive, of the boundary value problem dou y by dou x minus dou y by dou t, which is equals to 1 minus e raised to the power minus t with y of x comma 0. Y of x comma 0 is x. Okay, y of x comma 0 is x. Okay, sir. So what is given? It is dou y by dou x minus dou y by dou t equals to 1 minus e raised to the power minus t, with my y of x comma at the time t equals to 0 is x. This is given. 1 and 2 is given. Okay, so here we are going to assume that Laplace transform of y of x comma t, this y of x comma t, y is a defined function x comma t only. Yes, suppose I am mentioning it is y, means it is nothing but y of x comma t only. Y of x comma t only. This will be written as y bar of this x comma s, x comma s. Okay, now, yeah, Laplace transform of, taking Laplace transform on both sides of this, dou y by dou x minus Laplace transform of dou y by dou t equals to Laplace transform of 1 minus e raised to the power minus t. So first derivative with respect to x means what? So compute this. With respect to x means first the ordinary derivative of y bar, right? Is it clear?
Yes, sir.
So it is dy bar by dx minus dou y by dou t means partial derivative with respect to the y with respect to t means x s into y bar minus y at x0, right? Okay, so here we are going to substitute the remaining thing. Okay, s into y bar of x comma s minus y of x comma 0, which is equals to Laplace transform of 1 is 1 by s minus e raised to the power minus t means 1 divided by s plus 1. S plus 1. So what is given? Y of x comma 0 is x. So this can be replaced by x. So s into y bar of this x comma s minus this x, and dy bar by dx minus this is 1 by s, 1 by s, or we may take it as an LCM form. Okay, so it's again LCM form. Okay, it is s plus 1 minus s means it is 1 upon s into s plus 1. Am I right? So here it is dy bar by dx. The problem is defined as, this problem is defined as minus sy bar, dy by dx minus sy bar equals to 1 divided by s into s plus 1 minus x. Sir, is it clear?
Yes, sir.
So if you are look at these equations, this is nothing but is of the form p dy by dx plus py equals to q form. Let us assume that the form of this equation is dy by dx plus py equals to q. So it's a first order equation, first order linear differential equations, So what will be the solution? Dy by dx plus py equals to q means the solutions will be y into e power integral p dx. Am I right?
Yes, sir.
Equals to integral q into e power integral p dx into dx plus c. Am I right? So just using this. Okay, so this is not in our part. For understanding purpose, I'm just wrote it here. Okay, so dy by dx. So y integrating factor. Okay, so the integrating factor I'm just trying to find it. Okay, so the integrating factor, which is nothing but e raised to the power integral p dx. This is nothing but e raised to the power integral. What is my p? Just compare the two things. P is minus s, right?
Yes, sir.
Yes.
minus s, and here it is x is that variable is also in x and x. Okay, it is dx. Okay, so e raised to the power minus x into dx is e raised to the power minus x sx. Okay, so the solution will be of the form, here it is y, but for us it is y bar. For us it is y bar. Okay, y bar into e raised to the power integral p dx, e power integral p dx, this integrating factor is e raised to the power minus sx equals to q will be 1 divided by s into s plus 1 minus x, this right hand side of this term. This is entire term, it is considered it as q. Okay, 1 divided by s into s plus 1 minus x into e raised to the power minus sx dx plus that integral constant c will be added. Sir, is it clear?
Yes, sir.
Okay, now just try to integrating these things. Okay, 1 upon this s by s minus s and all. Okay, so here with respect to the x only, here we are going to integrate. So the first term 1 divided by s into s plus 1 will be the constant for this. Remaining it is e raised to the power minus s dx. Then remaining it is integral s into e raised to the power minus sx dx plus integral constant. So here we are having that. Here we are having that this is 1 divided by s into s plus 1, and e power minus sx is e power minus sx divided by minus s, right? This is the part. This is the part here we are. Okay, and remaining it is just the Bernoulli's formula you may apply. Bernoulli's formula. So we may get this separately if you are applying. So Bernoulli's formula, if you are applying, the resultant will be here we are having that in this way. Okay, e power minus s by s plus integral constant c. So overall my y bar of x comma s is this is minus mm, minus e raised to the power minus sx divided by, this is s square, right? S square into s plus 1 plus this x by s e raised to the power minus sx plus 1 by s square e raised to the power minus x plus c. So integration, c is an integrating constant. Okay, so suppose we are actually here we have one more e power minus sx, right? E power minus sx, I just missed it. Y bar into e power minus sx. Okay, so with this suppose we multiplied throughout e raised to the power xx, so which will implies y, then minus 1 divided by s square into s plus 1 plus x by s into s by s only, then here it is 1 by s plus c into e raised to the power sx. Is it clear?
Clear, sir.
Yeah, fine. Now we want to apply the inverse Laplace transform. Y bar of x comma x means nothing but our y of x comma s. If I am taking this L inverse of this y of x comma s, or L inverse of this y bar of x comma s, means the meaning is that it is going to provide this y of x comma t. Okay, this is the meaning. Okay, this is the meaning. Okay, so here we want to apply inverse Laplace transform. Here, since we require the boundary solution, it follows that this y of x comma t should be bounded, okay, for all x and t. Hence this y bar of x comma x should be bounded. Okay, so here y bar of x comma x is finite, bounded means finite when this x tending to infinity, when x tending to infinity in your solution format, okay. So hence we must take this c is 0, this z is 0. See, when x tends to infinity, okay, e raised to the power infinity form here we are having, right? Actually, the condition should be y of x comma t should be bounded when x tends to infinity. When x tends to infinity, I think that is the theory also. Okay, when x tends to infinity, and it is half exponential order. So that just apply the inverse Laplace transforms. With that, the e raised to the power x cx, we are going to make it as 0. This is 0 form. Okay, to avoid that, remaining it is y bar of minus 1 divided by s square into s plus 1 plus x by s plus 1 by s plus 1 by s. Then L inverse of this y bar is minus 1 into L inverse of 1 divided by s square into s plus 1, or even here itself, even you may consider it is minus 1, not an issue. Okay, this is minus 1, here also you may take it. Okay, and here you may remove it, and then L inverse of x by s plus x is constant here actually, for 1 by s term only here we are taking it, and remaining it is L inverse of 1 by s. L inverse of 1 by s. That 1 by s also here we are taking it. Okay. So what is the transform of this? Here by partial fraction only we have to get, right? Am I right? Students?
Yes.
By partial fractions we may get it. Okay. The result I will give you. Okay. The result I will give you. So this can be written as this s square plus term. Okay, so the x into L inverse of 1 by s, this one term, remaining this divided by s square. One thing pa. So if we are applying partial fractions, what we are getting actually four times here we are having, right? A by s, b by s square plus c by s plus 1. 3 terms here we are having. Is it clear? So to avoid that, we without applying that, so what we can do that? See here, this y bar x by s first fixed, and then this 1 by s minus 1 by s square s plus 1. Shall we write in this way? Just consider. Suppose I am going to take 1 by s square. 1 by s square as common. 1 by s square as common. And I missed one s. I think that's a mistake. I am stucking the problem. Here it is s square. Is it clear? See here 1 by s, it is 1 by s square. The positive only I just concentrate, it is s square. So 1 by s square, now it is 1 by s square. So here also it is 1 by s square. So now if I am taking this 1 by s square, it is 1 minus 1 divided by s plus 1. Sir, is it clear? Sir, have you got the point?
Yes, sir.
Okay, so how can we write this? Is there s plus 1? S plus 1 minus 1 divided by s plus 1 means s upon s plus 1. This is s upon s plus 1 into this s square. The same thing, whatever we done, the same thing here we are having. Okay, so here if we are applying the inverse Laplace transform, now this L inverse of y bar and L inverse of x by s, okay, plus L inverse of s divided by, actually this s and s we can get cancels, right? So 1 upon s into s plus 1. Is it clear?
Yes, sir.
1 upon
Yes.
s into s plus 1. And this 1 upon s into s plus 1 can be written as 1 by s minus 1 by s plus 1. Actually, here if you are cross multiplied, we may get this, which means that my a is 1, b is minus 1. 1 by s into 1 by s into this x we may take out. Okay, so plus this L inverse of 1 by s minus 1 divided by s plus 1. So that's the condition. So L inverse of this is constant is 1, and this is L inverse of 1 by s is also constant, minus e raised to the power minus t. This is my y bar of, means it is y of x comma t. So this is the solution. So my solution, required solution is 1 plus x of t minus e raised to the power t. So that is the solution for this problem. This is y bar of x comma t. Y bar of x comma t, where x depends on t, or sometimes you may not write this x also. Okay, 1 plus x into t. So in this problem, actually what we done, just applying the Laplace transform, on the given first order PDE, the both the terms, and if it is with respect to x means the derivative formula, with respect to t means our usual formula, but two variables. Here it depends on two variables, not only one. That's why the partial derivative arises. Okay. So here we supplied this initial the boundary conditions. Sorry, it is the boundary conditions. Supply that. Okay, and if it is in the form of first order linear differential equation, why it is first order? Because here itself we are having the first order partial derivative only. So after applying that initial boundary conditions, here it is in the form of linear differential equations, first order linear differential equations. So finding the integrating factor and then using the solutions formula. Okay, so here only one thing, when if you are multiplied by this e power sx here, okay, when x tends to large, it is this y inverse. Okay, this y bar itself tending to infinity. Y bar itself, it is tending to infinity. So we try to make this c as 0. Then for the remaining three terms, applying the inverse Laplace transforms by partial fractions. Okay, then we may get the solution of the systems. Is it clear?
Yes, sir.
Okay, suppose we will see one more problem. Okay, one more problem. Okay, you just try to say that whether it is easy or not. Okay, solve the boundary value problem. Dou u by dou x plus 4 into dou u by dou t, which is equals to minus 8 times t, where t is positive and as well as x is also positive, with u equals to 0, with a equals to 0, when time t equals to 0, x positive, and it is u equals to 2t square, when x equals to 0, comma t is positive. Actually, it is a very lengthy problem. Okay, concept wise. Okay, it is boundary value problem. It is provided boundary value problem. Solution of this problem is, what is given? Given is dou u by dou x plus 4 times of dou u by dou t is minus 8 times t, with u at x comma 0. See, when x is positive, when time t equals to 0, u value becomes, it is 0. Okay, and this u of, when x is 0, t is positive, so u of 0 comma t is, it is 2t square. Sir, is it clear how we are writing the equation from this? So together this we are having this condition, and together this we are having these conditions. It is when time t equals to 0, when x is positive, so it is u value is becomes 0. And here when x is 0, when time is positive, then it is moving. So based on the function, it is 2t square. Is it clear?
Clear, sir.
Okay, plus 4 times of your dou u by dou t equals to Laplace transform of minus 8 into this t. Okay, so what about this with respect to x means it's du by dx, right? With respect to t means s into u bar of x comma s minus u of x comma 0 minus 8 times L of t means 1 by s square. Am I right?
Yes, sir.
Okay, now this du bar divided by dx plus 4 times of this s into u bar of x comma s. U of x comma 0 is 0. Simply it is 0 minus 8 divided by s square. So what is my given differential equations? Du bar divided by dx. Okay, plus 4 times s. 4 times s into u bar equal to minus 8 divided by s square. So this is linear first order differential equations. This is differential equations. So what should try to find the integrating factor? Am I right? E power integral p dx. So what is my p? Right? Is it clear?
Clear, sir.
Solution form u bar into e raised to the power integral p dx equals to integral q into e power integral p dx into dx plus c. Okay, plus c. Okay, now this u bar integral e power p dx is e raised to the power 4sx minus q is it is minus 8 divided by this s square, and then here it is e raised to the power 4sx dx plus c, and this integration with respect to x, so that it is minus 8 divided by s square is constant, e raised to the power 4sx divided by it is 4s plus integral constant c. This is u bar of e raised to the power 4sx. Okay, then what about this u bar? If I multiply it throughout the equations minus 4sx, so this will made it is 1. Okay, here it is 1. Then this will be cancels. So minus 8 divided by 4s cube into 1 plus c into e raised to the power minus 4sx. Is it clear?
Yes, sir.
Okay, and it is nothing but minus 2. If we are simplified this, this is minus 2 divided by s cube plus c into e raised to the power minus 4sx. This is my u bar of x comma yes. Okay, u bar of x comma yes. Okay, u bar of x comma yes. See here, if you are before applying the Laplace transform, it is u of x comma t. This u means this is u of x comma t. If you are applying this Laplace transform of u of x comma t means it is u bar of x comma s. The time domain to s domain here we are traveled. Okay, even inverse also. That's why I wrote here inverse also. If you are applying this s to t here we are having s to t. So that's basic things in your two variable calculus we have to understand. So this is my u bar of x comma things. Okay, and can you tell me what is the thing for your equations here? Laplace transform of u of 0 comma t. Nothing but Laplace of 0 comma t. The initial condition it is provided it is 2t square. It is 2t square, so that it is 2 times of t cube means it is 3 factorial divided by s to the power 4. Am I right? Or s cube?
X cube.
N factorial divided by s cube, right? It is n factorial. So 2 times of by s cube. So it is 4 divided by s cube. Is it clear?
Yes, sir.
Okay. So here I just try to write here and here. So applying that condition also, L of u of 0 comma t is Laplace of 2t square. The same thing I am writing here. So 2 into 2 divided by s cube. Okay. So this 2 divided by s cube, 2 divided by s cube. Okay, here we are having that. Okay, 2 divided by s cube. Or can be written as something like this can be written as in this way or other form. In this way, u bar of 0 comma s, because it is a Laplace transform I applied, right? Laplace transform of 0 comma t means x comma t means it is x comma s, where x is 0 means it is x comma s is nothing but 2 into this 2 factorial divided by this s cube, this s cube. Okay, so overall it is 4 divided by s cube. So we are writing in two different manner, just the notation wise. For this, the different notations. Okay, that's all. Okay, and come back to the problem. Okay, so here in this solution, suppose this is my star. Okay, in star, okay, this u of x comma s, which is minus 2 divided by s cube, minus 2 divided by this s cube, plus c into e raised to the power minus 4sx. Suppose here we are putting x equals to 0 because u bar of 0 comma s we are having. Okay, just putting x equals to 0 here. This is u bar of 0 comma s, and this is same as this 4 by s cube. Is it clear? Sir,
Yes, sir.
do you have the connectivity?
Yes, sir. Yes, sir.
Yeah, fine, fine. Now it is 4 by s cube, and remaining it is here what we are having. It is minus 2 divided by s cube plus this, when x is 0, e power 0 is 1. So only the constant here we are having. So that from this the constants can be computed. So 4 plus 2 divided by this s cube. So that 6 divided by s cube is my constant. So again from my our star. Okay, from star u bar of x comma s is c into this e raised to the power minus 4sx minus 2 divided by this s cube. Here we are having that c is 6 by x cube. So 6 divided by this s cube, 6 divided by x cube into e raised to the power minus 4sx minus 2 divided by this s cube. This is my u bar of x comma x. So what we have to apply now? By taking inverse Laplace transform. Laplace transform of this u of x comma x is so yeah, Laplace transform of this 6 divided by s cube e raised to the power minus 4 s x minus 2 into a Laplace transform of this. Even 2 also we may take. Okay, 1 divided by this s cube if I am taking. Okay. Even this 2 also we can maintain inside because it is, yeah, it is 2 divided by s divided by t square, and 2 plus 1 means then that will be 2 square t square. Okay, here it is minus t square I may take. Am I right? Sir, am I right?
Right, sir.
Okay, then for this 6 I am taking out. Actually it is inverse Laplace transform. Sorry, it is inverse Laplace transform. ILT, inverse Laplace transform. So here last class we discussed that L inverse of this exponential functions multiplied with some function of x means then this x functions will be denoted by heavy side of, am I right? Heavy side of minus 4x, and remaining L inverse of this 1 divided by s cube is L inverse of 1 by s cube. Okay, here I may take it as by 3 into 2. Okay, this 6 I may take it as 3 into 2. So L inverse of this 2 divided by s cube is, it is t square, but the t square, t should be replaced by t minus 4x. T should be replaced for these functions only. For this only, not here, because this is not in the form of e power minus 4x. So that it is t minus 4x whole square, heavy side of t minus 4x minus t square. That is your u of x comma t solution. I think this 3 I should write, right? Is it clear?
Yes, sir.
Yes, sir.
Okay, so in this way you can solve for. Okay, so this is your module number 4 is over. Okay, your entire module number 4 is we completed. This material I will share. So the only thing here we have to discuss in tomorrow class. The Fourier series and the Euler's formula, Dirichlet conditions, and the change of interval. Okay, and don't worry about it. Okay, I will come up with the material like our previous class. Okay, so here I am writing everything. So that's why it takes around 1.5 hours to complete this half of the things. Okay, but if I am the definition, most of the things here we are involved with the definitions and some conditions. Okay, that conditions and all I just come up with the material. So the problem, if you are solving, then that tomorrow class by that we are having 2 hours class, right? Continuously. Am I right?